Next question is to minimize the following DFSM. So here also the DFSM is given in the form of a transition table where initial state is A and final state is D. So let summation be 0, 1. We'll see the operations of minimizing the DFSM at each step. So initially there will be two classes. One class consisting of all final state or accepting states. So here it is only D. And another class consisting of all non-accepting states. So in this class all the non-accepting states are A, B, C, E, F, G and H. So initially we have two classes. Next is we have to check whether this class is further divisible or not. For that we have to find out A0, A1. So A0 is going to be, B is in the second class. So A0 goes to the second class. A1 goes to A. So that is also in class 2. A, B, C, E, F, G, H. B0, B0 is going to A, that is class 2. B1 is going to C, C is again in class 2. Similarly, we have to find out for C0. C0 you can see here. C0 is going to D, class 1. So C0 is going to D. C1 going to class 2. E0 to class 1. E1 to class 2. F0 to class 2. F1 to class 2. Similarly, in that way we have to find out for all the states. So once we have obtained for all the states, we have to find whether there is a pattern. So here we see A, B, then F, G belong to one pattern. This is pattern 1. Okay. Then C and E belong to pattern 2 and H belongs to pattern 3. So there are 3 different patterns. We split into 3 classes. They are A, B, F, G in one class, C and E in second class, and H in third class. So finally, we at this state we have obtained A, B, F, G, C, E, D, and H, 4 classes. Again, we have to check whether these classes A, B, F, G, and C, E are again possible to split. So again find out A0, A1, B0, B1, F0, F1, G0, G1. Similarly, C0, C1, E0, E1. In all these, A0 is going to be, B is in first class, A, B, F, G. Similarly, A1 is going to A is in class 1. B0, A is in class 1. B1 is going to C is in class 2. So B1 going to CE. So in this way we have to obtain for all the states. Again we have to check the pattern. So if we see the pattern here, A and G belong to the same pattern P1. B and F belong to the same pattern 2. and C and E belong to pattern 3 as they are similar with each other. So there are three different patterns obtained. A, G, B, F, C, E and D, H. So next again we have to find out, is it possible to split AG and BF? So again find out AG, A01, G01, B01, F01. So if we find here A0 is going to B. B is in BF class. A1 is going to 1, 1 is in AG class. So in this way if you find out, you can see here A and B, A and G belong to the same pattern. Similarly, B and F belong to the same pattern. So, no more split is required. And finally, the classes obtained are AG, BF, CE, D and H. The minimized DFSM consists of the states AG, BF, CE, D and H, where A is the initial state. Wherever we have A, that will be the initial state. D is the final state, so D is the final state. Coming to the delta transitions, first state is AG. AG, for 0 they are going to B and F. For 0 they are going to B and F. A1 is going to A, G1 is going to G. So AG, for 1 it is going to AG, that is a self loop. Next coming to BF. B0 it is going to A, F0 it is going to G. So BF for 0 is going to AG. B1 C, F1 E. So BF for 1 they are going to state C, he. Here only you will come to know whether your answer is right or wrong, because both the states must go for a given input symbol to the same state. They cannot deviate. Then only your minimized DFSM is correct. So you can verify your answer here only. Next, coming to CE. C0 is going to D, E0 is going to D. So CE0 is going to D. Next, C1 is going to B, E1 is going to F. CE1 is going to BF. Next, D0 is taking a self loop 0. D1 is going to A. Last H is going to G. H is going to G for 0 and for 1 it is going to D. So this is the complete minimized DFSM. But one thing to be noted here, if you check, AG is the start state, BF state is reachable from AG, CE is reachable from the start state AG, D is reachable from the start state AG, whereas H state is not reachable from the start state. Since it is not reachable, no need of having state H. Either you can eliminate this H at the start or you can eliminate at the end of the state. So on eliminating H, this is the final minimized DFSM obtained. Therefore, the complete DFSM is M is equals to Q summation delta Q naught F, where what is Q? Q is having states AG, BF, CE and D. Summation is 0, 1. Initial state is AG. Final state is D. Last delta, either you can write the delta transitions or you can write the transition table. I'll just write the transition table here for 0, 1. Initial state AG, BF, CE and D. AG for 0 it is going to BF. For 1 taking a self loop. BF0 is going to AG. BF1 is going to CE. CE0 is going to D. 1 is going to BF. D0 self loop. D1 going to AG. So this is the complete definition of the minimized DFSM.